Hello guys, today we're going to be going over the 2012 AP Calculus AB free response question number 5. This question sadly is no calculator, so you may not use a calculator on it. However, you really do not need to. So let's just get into the question. One thing to note though before we do is that you won't get points just for answering the questions. You'll also need to provide work, and I'll get into exactly what you need to write down in order to get full credit. Okay, so the question basically gives us some information at the beginning, and it says, the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams at time t days after it is first weighed, then db over dt is equal to 1/5 times 100 minus b. This formula is really important because it helps us solve one of the questions, and what it's basically telling us is the rate at which the weight of the bird is growing based on its current weight. And then it goes on to say, let y equal b of t be the solution to the differential equation above with the initial condition b of 0 is equal to 20. So that's really important because we'll probably use that initial condition in one of these sub-questions. So let's start off with the first letter, which is A. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. So in order to know how fast the bird is gaining weight, we'll basically use this formula because it tells us what dB over dt is. And this question is actually really simple. So we basically just take dB over dt. Let's write that down. 1/5 times 100 minus b, and then just plug in our different weights. So let's say our current weight is 40 grams. We just plug that in, so 150 times 60 is equal to 12. So we're basically growing weight at 12 grams per day when we're at 40 grams. When we're at 70 grams, we're growing weight at 6 grams per day. So the question asks, when is the bird gaining weight faster? That is obviously at 40 grams, because 12 grams per day is much more than 6 grams per day. B, and you actually have to explain the answer, by the way. B. So B basically asks us to find the second derivative in terms of B, and then it says use the second derivative to explain why this graph why the graph of B cannot resemble the following graph, which they give to us. So let's just quickly find the second derivative. So again, let's write down dB over dt is equal to 1/5 times 100 minus b. Let's just make this a bit more simple and multiply that out. If we take the derivative of that, then we get negative 1/5 dB over dt. And that's a common error. People might forget that when you take the derivative, you actually have a dB over dt there. And the reason why is because we're taking the derivative with respect to t rather than with respect to b. Or when you take the derivative of any other variable besides t, you have to show that it was in respect to t, so you have to write down dB over dt. And that's something really big that could completely throw you off the question. And now we can just substitute this back in here. So we get negative 1/5 times 1/5 times 100 minus b, which is, just to simplify, negative 1 over 25 times 100 minus b. So now that we have the second derivative, we have to figure out why the graph of b cannot resemble this graph. So the second derivative basically tells us about concavity. So what we're going to do is we're basically going to look at the concavity of this and determine whether that concavity could exist on this graph. So now we know, since this part is the weight, the 100 minus the current weight, and we know the current weight will never be above 100 grams. We know that this will always be positive, however, this is negative, which means that the concavity will always be negative and it will always be concave down. However, in this graph, if you look, there's a part that's concave up. Only this part is concave down. This part is concave up, which means that this graph cannot resemble the graph of B. Perhaps this isn't the graph, but I'm saying like the graph would resemble this in that the whole thing is concave down. So now let's move on to C. C states use separation of variables to find y equals b of t. And as Mr. Happ said, the separation of variable questions are really easy. So we're going to have a lot of fun with that. That's going to be really awesome for us. The particular solution to the differential equation with initial condition b of 0 is equal to 20. So again, that initial condition comes up. And since we didn't use it on the previous problems, we're probably going to use it on this one. So let's first just start off with our equation. So dB over dt equals 1/5 times 100 minus b. Now let's group up like variables. So 1 over 100 minus b, dB is equal to 1/5 dt. Now we take the antiderivatives of these. So ln, negative ln of 100 minus b is equal to 1/5 t plus c. There's two common mistakes that occur here. The first of which being that people forget this negative. When we take the derivative of this, by chain rule, this negative is going to come out of here, so we want to cancel that out with this negative in order to make this positive. The second common mistake is that people will forget this plus c, and you really need to remember it because the constant of integration is worth 3 out of the 5 points of this problem, and at max, as the problem states, you can only get 2 out of 5 points if you don't have that constant of integration, because there's a lot of steps you show when solving for that will help you get those points. So our first step is to find our constant of integration c. We do that with the initial condition, so that's where that's coming into play, which is b of 0 is equal to 20, so let's just plug that in. 0 plus c is equal to negative ln of 80. And just to point out something, we actually don't need these absolute value signs because b is always going to be between 20 and 100, so this will always be positive, which means that you don't need absolute value because it'll never be negative, right? It's always going to be positive. So c is equal to negative ln of 80. Now let's just plug that back into the equation. So 1/5 t minus ln of 80. Now we're going to want to isolate b, because that's b of t, and that's what we're really trying to find here. So let's just first multiply each side by -1 just to get that out of the way. So in order to get rid of this ln, we can use each side, we can set each side as a power of e, so do this. And now, what we're going to do is, we know that this will cancel out, so it becomes 100 minus b is equal to, and what we're going to do here is we're going to say e to the 1/5 t times e to the ln of 80, because we can actually separate that, right? That's one of our rules, and what this is going to help us do is bring this down as an 80, because e to the power of ln of 80 is just 80, right? Of t is equal to 100 minus b, and so then that makes it really simple. We find that b of t is equal to 100 minus 80 e to the negative 1/5 of t. And t is more than or equal to 0. Okay, so hopefully this video helped you guys. It should have been pretty informative, and this question was actually not one of the hard ones, so you guys probably didn't struggle with it that much. I'm going to roll some problems down the screen that will help you if you need further practice with this concept. We mainly just used separation of variables and just antiderivatives and things such as that. It was not actually that difficult, so hopefully you guys did not. So hopefully this really helped you guys, and thanks for watching.